Hello everyone, welcome to today's video on adding and subtracting rational numbers, and that's going to involve also finding distances between numbers. So the first key concept is that all the rules you've already learned for adding and subtracting integers are also true for adding and subtracting rational numbers. Those are to add two numbers with the same sign, meaning we would have two negative numbers or we have two positive numbers. You add the absolute values of the numbers, and then we keep the sign. So if we have two negative numbers, we can kind of like ignore the sign, think of the absolute value, add the two numbers, and then it's going to end up being negative. So you keep the negative sign. And then when you add two numbers with different signs, meaning you have one positive and one negative that you're multiplying, the order doesn't matter, then you're going to subtract the absolute values of the numbers and then keep the sign of the number with the largest absolute value. Remember, if we see subtraction, subtracting is the same as adding the opposite of the number. Okay, so you can always rewrite subtraction problems as the equivalent addition problem and then use these rules above. So we know that rational numbers are numbers that can be written as a fraction of integers. So they often are written in fraction form. So adding and subtracting rational numbers will look like adding and subtracting fractions. Remember, to add and subtract fractions, you have to find a common denominator first. So you see this over here. To add fractions, you need to have the same denominator or a common or like denominator. And then you keep that denominator in the bottom and you add the numerators. Rational numbers can also be expressed in decimal form. We're going to just make sure that the decimal points and place values are lined up. So we just see this down here. When you're adding 3.21 plus 4.5, you're going to line them up so the decimal points are on top of each other, and then you just add straight down. And then our last note is that if you're given one number in decimal form and one number in fraction form, you're going to want to convert one of those into the other form and then either add them as decimals or add them as fractions. It's hard to add fractions and decimals when they're in different forms. Okay? All right, so let's look at our first example, which will have a word problem. Example 1. A fish is at the surface of the ocean and then descends 2 1/3 feet. Then the fish swims down another 3 1/6 feet. What is the location of the fish relative to the surface of the water? Okay, so let's get a picture. It's going to help us out here, and it'll connect to a vertical number line. So like we've done before when we've been working with integers, we're going to consider the surface of the ocean, sea level, that's going to be our 0. I have a fish, starts at the surface of the ocean, and then descends down 2 1/3 feet. Okay, so we're going down 2 1/3 feet. Now, what number, rational number, represents going down 2 1/3 feet? Well, I already said that. That's negative 2 1/3. Okay, we know that descend means to go down, so that's going to tell us we have a negative number. Then the fish swims down another 3 1/6 feet. So from that position, then we're going down another 3 1/6 feet. Okay, and we need to figure out what is the location of the fish relative to the surface of the water. So how far is this distance total? How far did the fish go down? Okay, so how can we represent this with numbers, with an equation? Well, there's two ways. We can represent this as an addition problem or as a subtraction problem. Okay, I'll start with subtraction. I have negative 2 1/3 feet. That's the fish's point after it's descended 2 1/3 feet. And then I'm going to subtract another 3 1/6 feet. So I'm going down 3 1/6 feet after that. So that would be represented as a subtraction problem, or I could represent it as the equivalent addition problem. Subtracting is the same as adding the opposite. So I'm going to add the opposite of positive 3 1/6. What's the opposite of positive 3 1/6? Negative 3 1/6. Okay? So that is slightly more, I guess, maybe how you might think about it in my picture since I made them both red. But either way, we have these down arrows, or if we were thinking about a horizontal number line, it would be like left arrows going in the negative direction. And now we just need to add these to see what is this value right here. Okay, what is our location relative to 0 or the surface of the water? So now we need to add these negative rational numbers. We have that these are both negative numbers. Okay, so we can go back to our rules if we need to. To add two numbers with the same sign, which is what we have here, two negatives, add the absolute values of the numbers, and then we're going to keep the sign, so keep the negative sign. Okay, so I'll take the absolute value of negative 2/3 and the absolute value of negative 3 1/6. The absolute value of negative 2/3 is, of course, positive 2 1/3, and the absolute value of negative 3 1/6 is positive 3 1/6. So we're going to add those, and then remember at the end, our answer has to be negative. Okay, so then it just becomes a question of what's 2 1/3 plus 3 1/6. There's many options for how to do this. You can convert both of the numbers into improper fraction form, and then you can kind of do this work here in yellow where we're just keeping the denominator, the common denominator, and you add the numerators. But I think it would be good to try to represent what these means and see where all these things come from. So 2 1/3, that's the same thing as 2 plus 1/3. Okay? And then 3 1/6 is the same thing as 3 plus 1/6. So if we think kind of in the realm of like terms, we're all adding here, so these parentheses actually aren't doing anything. So I'm just going to get rid of them. I can combine the whole numbers together and then the fractions together. Okay, so I can do 2 plus 3 and then 1/3 plus 1/6. Right, that's the same thing. Okay, 2 plus 3 is equal to 5. And then we need to figure out what's 1/3 plus 1/6. These do not have a common denominator. So right now we cannot just add these fractions. We need to get a common denominator. Okay, so we're looking for a common multiple of 3 and 6. So the multiples of 3 are 3, 6, 9, 12, going on forever. The multiples of 6 are 6, 12. Oh wait, we already have one. 6 is a common multiple. We're going to keep 6. That's the denominator we want. And then we need to get from 1/3 to it's an equivalent fraction with a denominator of 6. Okay, so how do I get from 3 to 6? By either multiplying or dividing. That's how we come up with equivalent ratios. 3 times 2 is equal to 6. So we can do the same thing in the numerator then. 1 times 2. Okay, so 1/3 is equal to 2/6. So once I've done that, I have 2/6 plus 1/6. Now I can just follow this rule. To add fractions, we add the numerators and then keep the common denominator. So in the numerator, we have 2 plus 1. 2 plus 1 is equal to 3. And then the denominator, we keep 6. So we get 3/6. We can reduce that, so we have one last step to simplify or reduce that. 3/6 is equal to 1/2. That should make sense to you. 3 is half of 6. Okay? All right, so 1/3 plus 1/6 is equal to 1/2. That means that 2 1/3 plus 3 1/6 is equal to 5 plus 1/2. And 5 plus 1/2 is just equal to 5 1/2. Now we did so much work there. So it's really easy to be like, okay, my final answer is 5 1/2. But no, our question was not 2 1/3 plus 3 1/6. It was negative 2 1/3 plus negative 3 1/6. We had two negative numbers, we added their absolute values, and now we have to keep that negative sign. So my final answer is going to be negative 5 1/2. And you see I have a lot of work here, so that's why it's important to box it in so there's a clear answer. Okay, this is equal to negative 5 1/2. So the fish ended up 5 1/2 feet below sea level, below the surface of the ocean. All right, so let's look at example 2, which is not a word problem, which I'm sure might be nice for you. We're going to find the difference of negative 0.35, or 35 hundredths, minus negative 1/4. So this is complicated because we have one fraction and one decimal that we're subtracting. However, like I say on my first page, if you're given one number in decimal form and one number in fraction form, you're just going to want to convert one of them to the other form and then do the work. And 1/4 is a pretty easy decimal to come up with. So we're going to convert this negative 1/4 into its equivalent decimal form. what I'm going to do off the bat is I'm going to convert this subtraction problem into the equivalent addition problem. Subtracting -1/4 is going to be the same thing as adding the opposite of -1/4. What is the opposite of -1/4? +1/4, exactly. All right, so now at this point we have an addition problem. It's already looking nicer, a lot nicer, but I still want to get 1/4 into its decimal form. So it is really important for you to know that 1/4 is equal to 0.25, 25 hundredths. The way that you can think about that is if you think about a quarter, which is 1/4 of $1, it's worth 25 cents. So now I have -0.35 plus 0.25, or -35 hundredths plus 25 hundredths. So here I have one negative number and one positive number that I'm adding together. When I do that, these are the little bit trickier cases. I have different signs. I need to subtract the absolute values of the number and then keep the sign of the number with the largest absolute value. The absolute value of -35 hundredths is positive 35 hundredths, and the absolute value of positive 25 hundredths, or 0.25, is 0.25. Okay, so then we just need to subtract. So we'll do 5 minus 5. 5 minus 5 is 0. And then we have 3 minus 2. 3 minus 2 is 1. Carry down the decimal point, and then 0 minus 0 is 0. Okay, so the difference is 0.10, or 10 hundredths. Now we just need to figure out, should my final answer be -10 hundredths or positive 10 hundredths? So the absolute value of -35 hundredths was positive 35 hundredths, and the absolute value of positive 25 hundredths was positive 25 hundredths. So which of these two numbers is larger? Yeah, 0.35. Thus, -35 hundredths has the greatest absolute value, so that's the sign that matters. And so our final answer then, this difference, is going to be equal to -0.1 or 0.10. All right, now let's look at one final example, example 3, about finding distance. So we have example 3, a woman is fishing. She is sitting in a boat 3½ feet above surface level of the water. Her pole catches a fish 4½ feet below the surface of the water. How far is the distance between the woman and the fish? All right, I'm going to draw a picture again, because I think that's super helpful for these questions. Okay, so our fish is down here at -4½ if we represent it on the number line, and she's up here at 3½ positive 3½ Okay, how far is the distance between the woman and the fish? So, definition of distance. To find the distance between points on a number line, take the absolute value of the difference of the points. So we just have to subtract the value of the two numbers and then make a positive. Okay, so we can actually do this in either order. We can either take the absolute value of this positive 3/2, and then the difference, again, means we're subtracting -4½ Or we could switch the order around. We have -4½ and then we subtract positive 3½ because these are our two values. We have this positive 3½ and we have a -4½ So we just need to find the difference of those numbers, subtract them, and then find the absolute value, make it positive. Okay? The way on the left is going to show you how I would kind of do this problem. I'm going to turn that into addition. I'm currently subtracting -4½ So that's the same thing as adding the opposite of -4½ What's the opposite of -4½ Positive 4½ So we get that the distance is 8 feet. I would, just looking at this picture, I would say, okay, this distance, 3½ to 0, that's 3½ And then what's the distance from 0 to -4½ That's 4½ right? So that's where I was here, and then I'm going to add them up. So I would just do that. I don't necessarily always think in these terms when I'm doing these questions if I have a picture. But if you don't have a picture, or just generally, it's good to understand that we can subtract points to find distance, and then it just has to be positive. All right, very quickly, I'm going to do this over here. Either way, we get that that distance is 8. So that's a cool thing. The order doesn't matter, so you don't have to worry about which one you put first. Distance is 8 feet. Awesome. Great job, everyone.